Hey guys, here are your 6-6 Day 2 Rational Exponents notes. So I know we took a quiz on section 6-6. However, I wanted to take that quiz just while it was keeping it real simple. So in the first day of 6-6, you saw how to change a rational exponent into a radical and a power in order to simplify it. Now you just need to be able to work with these rational exponents. So before we had all these exponent rules, like when to add them, when to subtract them, when to multiply them. Now you have to be able to do that if the exponents are fractions, okay? So it's still pretty easy. All right, so let's review exponent rule number 1. We know that when we multiply the same base, we get to do what with our exponents? We get to add them. That's exponent rule number 1. All right, so look at the following examples that go along with rule number 1. They're asking us to simplify, right? So if you were asked to take x to the third and times it with x to the fourth, we have already learned this exponent rule that if we are multiplying the same base, I can just turn this into x to the 3 plus 4. And then we add our exponents and our answer is x to the 7th power, right? Because I would have multiplied x by itself 3 times here, 4 times there. I would have multiplied x by itself a total of 7 times, right? All right, so that's what we did when it was just whole numbers. So now it's going to be able to do the exact same problem with fractions. So if they ask you what's x to the 1/2 times x to the 3/2, that's going to be x to the, add your exponents, 1/2 plus 3/2. Now, adding fractions, you have to have the same denominator, but we already do. So this is going to become x to the, now we add our numerators, 1 plus 3 is 4, over a common denominator of 2. And then we simplify. This is going to be x to the, what's 4 divided by 2? 2. X squared is your final answer, okay? So it's your same exponent rules. You just have to be able to do them with fractions now, all right? And since, I'll come back to that one. All right, so part C, x to the 3/5 times x to the 1/4. Well, we're multiplying, the base is the same, we need to add our exponents. So this is gonna be x to the 3/5 plus 1/4. Well, now it gets annoying because now we don't have a common denominator, so you have to find one. So either ask your calculator or what's a common denominator between 5 and 4? It's 20, right? So to make this a 20, I have to times top and bottom by 4. So that's going to become x to the 12 over 20. Plus, to make this 20, I have to times top and bottom by 5. So that's going to be 5 over 20. And then it's going to be x to the 12 plus 5 is 17 over a common denominator of 20. And now if that fraction reduced, you'd want to reduce it. But it doesn't reduce, so you're fine. All right, look here. X to the, what power is assumed? First, times x to the 1/7. Well, if I'm multiplying the same base, I have to add by exponents. That's going to be x to the 1 plus 1/7, right? Well, 1 to make it a fraction, just put a 1 under it. So now I have to add 1 over 1 plus 1 over 7. So I have to get a common denominator. A common denominator between 1 and 7 is 7. So to make this 7, I have to times top and bottom by 7. So that's going to be x to the 7 over 7 plus, he already has a denominator of 7, so it stays 1/7. And then it's going to be equal to x to the 7 plus 1 on top is 8 over a common denominator of 7. If this reduces, we will reduce it, but it doesn't. So x to the 8/7 is your final answer, okay? So again, you're just adding your exponents. The bad news is you have to add fractions, okay? Let's try this one. So on the Delta Math homework, they ask you a lot of the questions like this. The example says, evaluate the left side to find the value of A in simplest form. So on the left side of the problem, they want you to take x to the 2/3 and times it with x to the 4th. It's going to equal x to some power. We have to figure out what power do they become, and then just that power is the answer they want us to find. They want us to find what A is. All right, so if we go here, it's going to be x to the 2/3 times x to the 4th. That's going to be, well, I'm multiplying the same base, so I need to add my exponents. It's going to be x to the 2/3 plus 4, and that will equal whatever x to the a is going to be. So I have to add these exponents together. So throw 4 over 1, and now a common denominator between 3 and 1 is 3. So it's going to be x to the 2/3 is good to go, plus to make this a 3 times top and bottom by 3, and that'll be 12 over 3. So that still equals x to the a. So now it's going to be x to the 2 plus 12 is 14 over a common denominator of 3. If this reduced or divided, you want to reduce it, but that is now what x to the a is equal to. So now you can see x to the a has to equal x to the 14 over 3. So a is equal to 14 over 3. And then that what you would type in as your answer. That's how the Delta Math homework is going to ask you to find the answers. They're going to ask you to find the value of a. All right, so they're basically asking you to find the missing exponent. All right, well, let's look at rule number 2 now. Rule number 2, when you're dividing the same base, our exponent rule said to subtract the exponents and put it back where the larger exponent was, because now it's going to have a top and a bottom, right, because it's division. So you always put it back on the top if the bigger exponent was on top, or you put it back on the bottom if the bigger exponent was on bottom. So we know to subtract the exponents, okay? All right, here we go. Look at it. Let's look at it with whole numbers first. So if you had x to the 5th divided by x squared, well, we're dividing the same base. We're going to subtract our exponents, big exponent, subtract little exponent, and put it back where it was. So we're going to go, it's going to go back on the top, and it's going to be x to the 5 subtract 2. Well, what is x to the 5 subtract 2? It's x to the 3rd. And it's back on the top because that's where the more x's were, where the larger exponent was. All right, let's look at this one. If you had x to the 4th divided by x to the 10th, right? Well, now your bigger exponent is on bottom. So now you're going to subtract your exponents and put it back on the bottom. So this is going to be x to the 10 subtract 4. And now since they moved to the bottom, you have to have a placeholder of 1 on the top. So it's 1 over x to the 10 minus 4, and then it's going to be 1 over 10 minus 4 is 6. 1 over x to the 6th is the answer here. So that was the division rule. Now you're just going to have to be able to do this if your fractions were your exponents were fractions. Okay, look at this example. If you had x to the 7 halves divided by x to the 1 half, well, you have to know which one is bigger. Would you rather 7 halves or 1 half? Definitely 7 halves is bigger. So your bigger exponent is on top. So you're going to subtract your exponents and put them back on the top. So this is going to equal x to the 7 halves subtract 1 halves, and we should be back on the top. So that's going to be x to the, luckily we already have a common denominator, so 7 minus 1 is 6 over a common denominator of 2, and if it divides or reduces, you want to do that, and it does. 6 divided by 2 is 3. So x to the 3rd is your final answer, and we're back on the top still. All right, let's look at example D. If I had x to the 1/3 divided by x to the 3/4. Well, first, we're dividing the same base, so we know to subtract our exponents, but you have to know which one is bigger. What's bigger, 1/3 or 3/4? It's 3/4, right? So you're going to take your bigger exponent, it's down the bottom, so we're going to put our answer back on the bottom, and we have to subtract our exponents. So this is going to equal x to the 3/4 subtract 1/3, and we are on the bottom, which means we have to have a placeholder of 1 on the top, right? Can't have an empty numerator. All right, so we have to subtract 3/4 minus 1/3. We have to get a common denominator, right? So what's a common denominator between 4 and 3? It's 12. So this is going to be 1 over x to the, well, to make 4 12, I have to times top and bottom by 3. So that's going to be 9 over 12. Subtract, to make 3 a 12, I have to times top and bottom by 4. So that'll be 4 over 12. And then that's going to equal 1 over x to the 9 minus 4 is 5 over a common denominator of 12. And now if 5 over 12 divided or reduced, you want to do that, but it doesn't. So that's your final answer. 1 over x to the 5/12. Okay? All right, look at here. Evaluate the left side to find the value of a in simplest form. So again, this is how Delta Math is going to ask you the question. What is x squared divided by x to the 5/6 and that has to equal x to the a. So we have to simplify this to find out what's the final exponent in the end, and then that is what what a is going to equal. All right, so here we go. So if we are dividing the same base, we know to subtract our exponents. Well, what's bigger? 2, which is over 1, so 2 out of 1, 2 wholes, divided by 5 out of 6. Clearly 2 is bigger than 5 out of 6, which isn't even a whole yet. All right, so our bigger exponent is on top, so it's going to be x to the 2 over 1 subtract 5 over 6. Well, and that will equal x to the a. All right, so I have to find a common denominator between 1 and 6. That is 6, so to get this to be a 6, I have to times top and bottom by 6. So that's going to be x to the 12 over 6 minus 5 over 6, right? And that's what x to the a will equal. All right, so on top, this will be x to the, what's 12 minus 5? It is 7 over a common denominator of 6. And that is what x to the a is equal to. So in this statement, what does a have to be to make the left side equal the right side? A has to be this fraction, 7 over 6. And that's what you would type in as your answer. Okay? All right, one more rule. The last rule was the power to power rule. When one exponent is raised to another exponent, what do we do with our exponents now? This is when we multiply them. And this rule is going to come in handy in the future when we start solving radical equations, okay? All right, so let's look at it first when our exponents are not fractions. All right, let's say we have to simplify this statement. X to the third raised to another power of 5, right? When one exponent is raised to another exponent, what do? We multiply. This will be, keep your base the same, x, multiply your exponents, 3 times 5, and your answer is x to the 15th. Okay, so this is not that bad. And even when it becomes fractions, multiplying fractions is the easiest operation we do. You multiply top with top and bottom with bottom, just straight across the fraction. So if I have x to the 1/5 raised to another power of 2/3, I have to multiply my exponents. So that's going to be x to the 1/5 times 2/3. And like I said, multiplying fractions is great. You don't need a common denominator. Just multiply the top and then multiply the bottom straight across. This will be x to the 1 times 2 is 2 over 5 times 3 is 15. And if that divided or reduced, you'd want to do that, but it doesn't, so you're done. This is x to the 2 over 15. All right, here we go. What about x to the 4th raised to another power of 1/7, right? Power to power, we multiply. So this is going to be x to the 4th times 1/7. Well, remember, I need a top and a bottom, so throw 4 over 1, and now multiply straight across. This is going to be x to the 4 times 1 on top is 4 over 1 times 7 on bottom is 7. And then if 4 over 7 divided or reduced, you'd want to do that, but it doesn't. So your answer is x to the 4/7. So that's really, really nice. All right, so again, this is one of the easier rules, I think. All right, last one. This is how Delta Math is going to ask you. Evaluate the left side to find the value of a in simplest form. So if we have to evaluate this expression, x squared raised to a power of 5/6 equals x to the a. Well, what does a equal? Well, what does this exponent become? So we're going to do power to power, we multiply. So it'll be x to the second times a power of 5/6. Well, we need not a common denominator, we need a denominator, so throw 2 over 1. And now we multiply straight across. And that is what x to the a is going to equal. So this will be x to the 2 times 5 is 10 on top, over 1 times 6 is 6 on the bottom, and that is what x to the a is equal to. But we always reduce fractions. 10 over 6 will reduce because 2 divides into both 10 and 6. So really this will simplify to x to the 5 over 3, right? Divide both of these by 2 and you get 5 and 3. And that is what x to the a ends up equaling. So in the end, what does a end up being? A ends up being 5/3. And that's what you would type in as your answer. Okay? All right, guys, so again, it's pretty simple. Basically, you are adding fractions, subtracting fractions, or multiplying fractions. As always, if you have any questions, please reach out to me and let me know, and I would be more than happy to help you. All right, good luck on your homework.